Next concept we would like to discuss is Callstack globals and local. To explain Callstack, I would like to tell you a story from Greek mythology. This was one of the stories which I've been told by one of my instructors when he taught me Callstack back in the days of Microsoft. So that story was the story of Theseus and Minotaur. I don't know if I am pronouncing it right, but I think it is. Minotaur was a big demon sitting in a huge maze or labyrinth, and he used to eat people. So the king had to give, periodically people to, as food to Minotaur. He was a creature which eats human beings, and a lot of people try to kill Minotaur. But because of the nature of this maze, everyone lost their way. Once they entered into the maze, they lost their way. They don't know how to come back. They wander inside the maze day in and day out. They get tired. Once they get tired, Minotaur will come and kill them. So that was the problem for killing Minotaur. And Theseus was a great warrior, and he commit to kill this monster and save the people. And so when he reached the country for the purpose of killing Minotaur, he will meet this princess, Ariadne. So she will fall in love with Theseus, and she was very, very smart. So she will tell him, hey Theseus, if you get into the labyrinth, you will die because you will lose your way. You cannot come back. So what she will do is she will give him a ball of thread, and he will tie one end of the thread to the outside, the gate of the labyrinth, and while he go inside, he will unroll or unwind the thread ball. And whenever he wants to come back, he always rewind it. So he will know exactly how to come back. Like that, he will go through all the routes inside the complicated labyrinth, and finally he will meet Minotaur. And as he was not lost way or not tired, he was always coming back to the gate to refresh himself. He was very fresh when he met Minotaur, and he will fight and kill Minotaur. So what is the reason for the story here? So a computer program is exactly like this. It's like a complicated maze, and the maze, each wall of the maze is functions. So different functions leading to functions. And Callstack and stack, Callstack, thread, that is the equivalent of thread. The concept, the word thread, comes into programming from this particular story. So the Theseus has used thread to find the way out of and into the different parts of the maze, which is the program. So when we debug, we are debugging a problem. So Theseus was at one place, he had a problem. So we are looking at the photo of that. Then we look at the thread or the stack. Then we will get to know what the problem was in that particular path. So the call stack is exactly same concept. What is call stack? Call stack is nothing but one function calls another function, that function calls again another function, so on and so forth. So that stack of functions which is calling each other is the call stack. So let's see that in a debugger. This is the same debugger which was attached to that notepad before. So this is the notepad which was attached to the debugger. So what I'm going to do is to see the call stack is already shown here, but to see the stack, I'm going to break into the debugger, breaking here. I'm going to switch to thread 0s, just to see an interesting thread which has value. The command for seeing the stack is K for call stack. This is the call stack, and this is the bottom of the stack, and this is the top of the stack. Call stack is slightly different from thread stack. although they are very closely related. Thread stack is a piece of memory where the local variable, return address, etc. lies. On the other hand, the call stack is more of a logical entity of the function call. This stack means that this function called this function, that function called this function, and so on and so forth. Finally, this is a function which is on the top of the stack. And that's where we broke the application. Always when you debug, you will be always looking for call stacks. Call stack is probably the single most important information when it comes to debugging. If you can't see the stack, probably you won't be able to narrow down the problem to a particular function. Probably you may not understand why, but when we debug the real problems, you will understand what is the reason for that. So like call stack, there is global variables. Global variables, we'll see how to dump global variables in different slides when we see DT command, for example. And local variable, we have already seen local variable here. For example, in this case, argc and argv are local variables. You can see the local variable by just clicking here. The actual command is dv. I don't want to explain dv right now because we'll see it later. These are the important information. Call stack, this is a call stack. I don't have any global variable in this program, but we will see shortly. But we have the call stack and we have the local variable. To get the local variable, I just clicked here. It will execute a dx command, which is what is done here. We will see the details later. So like I mentioned, call stack is the most important information when it comes to debugging. If you can't see the call stack, there are certain scenarios like stack corruption. You can't see the call stack, but you need to rebuild the call stack in a different way. But this is the most important information. So this is what you are hunting for all through this course. Next most important information is the local variables. If you can see what are the arguments passed to that function while the problem is happening, that's absolutely great thing. But in 64-bit, a lot of optimization doesn't allow local variables to be present on the stack. That is not always available. That is a luxury to have. Global variables are always available, as well as registers. They are like guiding lights. They will give you important clues when you do detailed debugging. So global variables, because mostly the stack variables are coming from global variables ultimately. So global variable gives us important clues and important information about the state of the program while the problem was happening. And we have explained the story of Theseus and Minotaur. If you want to read more, I think the story is there in the Wikipedia. This is Minotaur, different way Minotaur is being shown. This is the story which I was explaining and where the word thread comes. So we have seen this demo. One function calls the other function and generates the call stack. And we have seen that call stack as well.